Okay guys, in the last video I showed you all the project that I've been working on, which is a Zigbee decoder running on our FPGA, and then I showed you this module which is just taken straight out of that with one minor modification. Right here we have set the last bit to be 1 no matter what. And yeah, so now let's actually start planAhead. So I want to point out to you that this is planAhead version 13.1. The ISC project navigator that I'm using is 12.4, but I'm using the newest version of planAhead for my project. And so I'm going to start by not updating and going to create new project. And we'd like to create a planAhead project, so we hit next in the wizard that pops up. And you need to give it a name, generally a telling name. I'm just going to call mine planAhead because this is the planAhead section of my project that's being put in the same location as my project. So I'm going to click next. In order to do this, we've synthesized everything already, so we can give it a synthesized netlist, and we want this to be a PR project, so make sure you click PR project. Then hit next again, and we have to give it the top netlist file, so that's top.ngc. There are other modules in my folder. It's actually going to go ahead and read those in anyway, but we want it to read top.ngc. We hit next, and it asks for a constraints file. It's using the constraints file that I already set up for my project. Nothing's been changed. It's for the XUP-V5 LX110T board. Running a Vertex 5 LX110T. Right here you can see this is the FPGA I'm running. So it automatically found that from the constraints file, and I'll click next. And we're done. We can hit finish, and it will build the project for us. This takes a second to read in the netlist and set everything up, but really not that long. As you can see over here, it's found all of the modules again. The one we want to edit is top, so we're going to select it and go to flow and netlist design. This is going to read in the netlist. Remember when we synthesized it, we set it to keep the hierarchy. So this way when it reads netlist, it will actually see all of the modules that are implemented inside of it. I guess it's important to point out now that in your top level design, everything must be modulated. You can't have logic in your top level design. Everything's just got to be a set of modules. So here you can see all of the modules that we've set up. ZR0 is the one we're going to be playing with. If I expand it, you can see the files that are inside of it. The modules that are inside of it. So now let's make this a partially reconfigurable module. So we right click on it and we go to set partition. It opens up yet another wizard for us, so you click next, and this is a reconfigurable partition, or it will be when we're done with it. Click next, give it a unique name. I'm going to call this Zigbee Working because it's the working version of our Zigbee decoder. Hit next, and we're done. It read the netlist from the top level netlist, and there aren't constraints for it because it's just using the constraints from the original file. Excuse me. Okay, once we're done, it's added it. It's already made the change. So let's add the second module, since this doesn't really make much sense if we've only got one. So right click on 00 again and go to add reconfigurable module. It asks if you want to save the netlist. We've made a few changes, so sure. We hit a wizard again, click next, and give it a new name. I'm going to call this Zigbee or ZB and 1 because I'm forcing the least significant bit to be a 1. And we've already synthesized this netlist. Again, remember, this time without the hierarchy and without I/O buffer. You can also choose to just make it a black box, which is just an empty area inside of the partition. That doesn't really help us. So we're going to ignore it for now. Hit next. We have to give it the netlist file. Here's the folder that my project's in. Notice that I have the Zigbee Radio and 1 project as its own folder inside of this. So we're going to go in there, and you can see I have just one netlist in here. Again, for some reason planAhead likes reading in multiple netlists, so do keep your modules, especially the reconfigurable ones, in their own project and in their own folder so that it can determine that. Otherwise it tries to fit the whole design in there. So we select it, hit OK. I don't have a constraints file for it because again it's just using the original one. So hit next, and we're done. Hit finish. And it will add this module to the netlist. And here you go, you can see that ZR0 now has 2 reconfigurable modules, ZB working and ZB and 1. So we have to pick which one we want to be active. I'm going to start with ZB working. And right click on it, set as active reconfigurable module. And so now when we implement this, it will run through, it will set up static design, which is everything except ZR0, and then it will implement the working section, or the working module of ZB00. Okay, well now we actually have to floor plan this. It's generally a good idea to floor plan the biggest module that you have, which technically would be ZB and 1, but they're so close in this design it's not going to matter for me. But do make sure you use the biggest one, or the one with the most resources. We're going to go to Window and Physical Constraints, and you can see here the P block that it's set up for ZR0. When you select it, you get the resource estimates down in the middle left. They're all in red right now because there's nothing available, even though it requires quite a lot. So let's actually floor plan it. If you right click on the FPGA over on the right, you can go down to Set P block Size, and now we can drag a square here. Notice the only resources that I'm constraining are slices because it's all I need. I want to leave the other resources open and available for the rest of my static design to route to. Notice that this box is too small. You can see down in the resources that they're still red. You want to make sure none of them are red and that all of the utilizations are below 100. I'm going to go ahead and make sure mine are well below 100 so that both modules fit easily no matter what. You can click the box and move it around. I'll put it over here on the edge. And you can also drag it. So I'm going to click the edge of it, and now I can drag the size of it to anywhere I want. I'm again avoiding everything except slices. You can see here I've made this way too big. 62% utilization is great, everything will fit in it. But now, I'm wasting other space on my FPGA. So let's make it a little bit smaller. Now we're at 83%. That's probably still a little too big, but we're going to let that go. Again, you want to be conservative with this to make sure that it has room to route everything in this module and the other ones when it places them in there. So now's a good time to run DRC, which is the design rule checker, to make sure that we haven't broken any rules in this design. It's located right here in the project manager on the left, and also this button underneath of help at the top. When you click it, it asks for the things you'd like to run, all of the rules. I'm just going to run everything. You'll actually find that I've broken quite a bit of rules here. These are only warnings though, things that I didn't connect in my project earlier. That's my own fault. The project is kind of incomplete right now, but it does work in its current form, and as you see we have no errors, so it will make it to bitstream generation. So we're good. So now we're going to click on the Design Runs tab at the bottom here, and it's already set up the first one for us. This is Configuration 1, which will implement the static logic and the Zigbee radio, the Zigbee working radio. We can add another one by right-clicking and going to create new runs, and we're given another wizard. I'd like to hit next. We're using the same sources, the same constraints file, and the same FPGA, so we hit next. And here's the part that matters. It's going to go ahead and call it config2. We're using the same strategy. We don't want to make it active right now because we haven't even built the first one. And then here's the partition that we'd like to run. So it's still running ZB working. I'm going to click it and do ZB and 1. Now generally right here the static logic can be imported from the import file, but we can't do that until we've built the first one. So we're going to ignore that for now. And we hit next. And I don't want to launch it yet because the other one's not done, so it's ready. Hit next, and it creates the implementation. So now we can run it. What I'm going to do is right-click. Oh, excuse me. Click on Config 1 Active, and then you can right-click and go to Launch Runs. It asks what I'd like to do. I'd like to run this on 2 jobs because I have 2 processors. And again, it's showing me that it's config 1 that it's launching. So I hit OK. Do I want to save the project? Yes, I do. So it saves everything and then starts running. This takes quite a bit of time. because it's setting everything up and implementing it. So it'll take about the same amount of time as it would for you to build it in your ISC project. Once it's done, it'll ask what you'd like to do next. I'm going to tell it I'd like to generate the bitstream. Once that's done, over here on the left, you can see where it says promote partitions. You can't do that yet, excuse me, but once this is done, you'll want to click that and just hit the standard. Again, the wizard will walk you through everything, which will promote it to an area that lets me set this configuration. Again, if we go here to partitions, right here, import, you can import from the location that you import this to. Again, if it's the default, it will just set itself up for you. By importing this design rather than implementing it, which is the other option, we don't have to implement all of the static logic. It stays in the same place, so there's no point in implementing it all again. We're just configuring the new module, which is ZB&1. It will generate the netlist for this and put it in its own folder. You can promote that too if you'd like, but it's really unnecessary. Okay, so that's planAhead. It was that simple for us to go from a working ISC project to a planAhead project where we have now 2 modules. It's going to take a while to run, so I'm going to let this be the end of this video, and when we come back, I will show you these done, and we'll demonstrate it.